Hi, in this video we're going to talk about the remainder theorem and the factor theorem. At the end of the video, you should be able to find a remainder of a polynomial when divided by another using the synthetic substitution, and find all the factors of a given polynomial applying your factor theorem. Let's begin. A remainder theorem is saying if a polynomial f of x is divided by x minus a, the remainder is the constant f of a. F of a refers to the function notation, and that f of x is equal to q of x, which is the quotient, times your divisor x minus a plus your remainder f of a, where qx is a polynomial with degree 1 less than the degree of f of x, because quotient is always 1 degree lesser than the given dividend divided by x. Another way of explaining this is that dividend equals to quotient times divisor plus remainder. To make more practical sense out of it, let's say you have 9 divided by 2 is actually 4 with a remainder of 1. Dividend is 9 is equal to the quotient 4 times 2 plus the remainder 1. But since we're dealing with polynomials, let's see how do we deal with remainder theorem. This example is a simple arithmetic. Let's say if you have find f of 3 for the following polynomial function, you have f of x is equal to 5x squared minus 4x plus 3. F of 3 is just a simple function notation where you substitute 3 to all x's. And then simplify, of course. 3 squared is 9, 4 times 3 is 12. 5 times 9 is 45. 45 minus 12 is 33 plus 3, 36. That is f of 3. Now, let's set aside this one. Let's say you have the same 5x squared minus 4x, but this time we will perform a synthetic division. And remember, in your synthetic division, your constant changes sign when you write it on the left side. And then your coefficients are 5, negative 4, and then 3, and then start your cycle of your synthetic division. Bring down 5 times 3 is 15, add to 4, 15 minus 4 is 11, 11 times 3 is 33, 33 plus 3 is 36. Do you remember the result a while ago when we performed f of 3? Here it is. It's 36. Notice that the value obtained when evaluating the function at f of 3 and the value of the remainder when dividing the polynomial by synthetic method dividing by x minus 3 are the same. Dividend equals quotient times divisor plus remainder. Meaning to say, the synthetic division is just another way of determining your remainder when you are doing synthetic division. Now, what's the big idea? Well, if you have a given polynomial with a power of 4, degree of 4, degree of 5, and you have 3, can you imagine 3 times 3 times 3 times 3 times 3, and then simplify? It's a lot of work. This is where your synthetic substitution will be helpful to find a remainder of a given polynomial divided by x plus or minus a number. To make sense of the given, you have the quotient. No, the dividend is equal to the quotient 5x plus 11. This is 5x plus 11 times your divisor x minus 3 has a remainder of 6 plus remainder 36. If you multiply 5x plus 11 times x minus 3 plus 36, it gives you back your divisor, dividend, 5x squared minus 4x plus 3. Now, let's try that. This is what you call synthetic substitution. Now, synthetic substitution using synthetic division to evaluate a function. This is especially helpful for polynomials with degree greater than 2. Let's say you have the power of 3 already as the highest degree, or its degree of 3. When you are looking for f of 4, you just plug in 4 and then write down your coefficient 2, negative 4, negative 7, negative 13, and start your synthetic division. In this problem, we are actually looking for your remainder. And so let's begin your synthetic division. Bring down 2. 2 times 2 is 4. 8. 8 is added to negative 4. 8 plus negative 4 is 4. 4 times 4 is 16. 16 minus 7 is 9. 9 times 4 is 36. 36 minus 13 is equal to 23. And that is your remainder. Okay. So, can you imagine if you are looking for your value of x? If your x is 5, when you plug it in, it's a huge number. Here we have only negative 2. So, let's begin. You have 5, negative 13, negative 14, negative 47, and then 1. Let's begin your synthetic division. Bring down 5. 5 times negative 2 is negative 10, negative 23. Negative 23 times 2 is positive 46. 46 minus 14 is 32. 32 times negative 2 is negative 64. This will be 101, no, 111. Negative 111 times negative 2 is positive 222. Plus 1, 223. That's the remainder of your g of negative 2. This is supposed to be g. Okay. That's how you find the remainder. Instead of doing your actual long division, we can easily find your remainder using your synthetic division. At this time, it's called synthetic substitution. Now, what's the point of the remainder theorem? If you have a remainder, then let's say 6 divided by 2 is equal to 3. There's no remainder. 6 divided by 3 is equal to 2. There is no remainder. If you have 6 divided by 4 is 1 plus remainder 2. If there is no remainder, there is the number you're trying to divide to the dividend is a factor. In the sense of a algebra, the binomial x minus a is a factor of a polynomial f of x, even only if your synthetic substitution does not have a remainder, which results to 0. It does not end to a number but 0. Therefore, x minus a is a factor of the polynomial. Now, when a polynomial is divided by one of its binomial factors, the quotient is called a depressed polynomial. I'll show you what a depressed polynomial in a bit. If the remainder, last number in a depressed polynomial is 0, that means your second variable results to 0 is also your next factor. This also means that the divisor resulting in a remainder of 0 is a factor of the polynomial, and on and on. If you keep dividing and dividing, and it keeps you giving you a 0 at the end, there's no remainder. That's how you find your factors of a polynomial with a degree higher than 2. Remember, when you are factoring quadratic polynomial, you just have to figure out by a reversed FOIL. But if your polynomial has a degree of 4, degree of 5, degree of 6, this is where the factor theorem comes in. wherein you can still factor a polynomial with degree higher than 2. Let's have an example. Let's say this is your given. See, it's already x cubed. If it is an x squared, we can try your factoring, but factoring will be very difficult on this problem. So here's the given. Let's test if x minus 3 is a factor of the given polynomial x cubed plus 4x minus 15, x minus 18. If we divide this and then the result, the last number is a 0, then there is no remainder, therefore x minus 3 is a factor. That is the idea of a factor theorem. Let's begin. Write down your 3. Remember, when you do synthetic division, the number changes sign, the number after x. Write down your coefficients, 1, 4, negative 15, negative 18. And then start your cycle of your synthetic division. Bring down 1. 3 times 1 is 4. No, 3 times 1 is 3. 4 plus 3 is 7. 7 times 3 is 21. 21 plus negative 15 is 6. 6 times 3 is 18. So therefore, x minus 3 is a factor. Now, since the remainder is 0, x minus 3 is a factor. This also allows us to find the remaining factors of the polynomial by factoring the depressed polynomial. The depressed polynomial is your 1, 7, 6 because it's actually a polynomial. If you write it back into polynomial, it becomes x squared plus 7x plus 6. And this one, if you remember your factoring, you factor the last, you factor the first. Factor of first is x times x. Factors of 6 can be 1 plus 6. 1 times 6 because 1 times 6 gives you 7. And amazingly, we were able to factor x cubed plus 4x minus 15, x minus 18 by synthetic division. The factors are x minus 3 because if we divided it, it results to 0. And then we just tried simple factoring. X plus 6, x plus 1. Without calculator, we were able to factor a polynomial of degree 3. Another thing, you can actually continue your synthetic division. If you tried to extend a line here and write negative 6 here or negative 1, it will read you to 0. Let me show you another example. We have 2 more examples. Let's begin with number 1. Write down your 8, positive, your x cubed 1, negative 11, positive 14, 80. Let's test 8. If this results to 0 at the end, then it is a remainder. It is a factor. X minus 8 is a factor. Bring down 1. 1 times 8 is 8. 8 minus 11 is negative 3. Negative 3 times 8 is 24 negative. Negative 24 plus 14 is actually negative 10. Negative 10 times 8 is negative 80. And it is a 0. Therefore, indeed, x minus 8 is a factor. According to the instruction, given a polynomial and one of its factor, find the remaining factors of the polynomial. Some factors may not be a binomial. So here, since it resulted to 0, x minus 8 is a factor. Now, instead of factoring, instead of writing it back into a depressed polynomial, we can actually continue the synthetic division. And it's a guessing game this time. But you don't have to guess too much. The numbers that could probably be here are numbers of factors of negative 10. Let's say 5. So let's start trying. Bring down 1. 1 times 5 is 5. 5 plus negative 3 is 2. 2 times 5 is positive 10. Amazingly, when you add, you have a 0. And you are actually done. Because your factors are, by the way, this 1 and 2 actually now can be written in a depressed polynomial x plus 2. And so your first factor is the x minus 8 because of course it resulted to 0. Watch out, see how negative 8 but on your synthetic division, it's positive. Therefore, since this is positive 5, your next factor is x minus 5. And your last factor is x plus 2. And we were able to factor a polynomial with a power of 3. The factors are x minus 8 times x minus 5 times x plus 2. If you're going to multiply all of this, it gives you back your polynomial of degree 3, x cubed minus 11x squared plus 14x plus 18. Let's have your second and last example. To begin, let's test if indeed this is a factor, because if you perform synthetic division, you should end up with a 0 and not a number on the very last column result. Let's begin. You have negative 6, and then your coefficients are 2, 7, negative 33, negative 18. Start your synthetic division, bring down 2. 2 times negative 6 is negative 12. Negative 12 plus 7 is negative 5. Negative 5 times negative 6 is positive 30. 30 minus 33 is negative 3. Negative 3 times negative 6 is positive 18. And you have a 0. Therefore, indeed, x plus 6 is a factor. Now, let's continue. Instead of writing it back into a depressed polynomial, we can continue with your synthetic division. And it's a guessing game again, so you don't have to guess too much. Probably it's a 3. Is it a positive or a negative? Actually, it's a positive 3. Let's try. If indeed it's positive 3, or your next factor is x minus 3, bring down 2. 2 times 3 is 6. 6 minus 5 is 1. 1 times 3 is negative 3. And we are done. First things first, your 2 and 1 here is your depressed polynomial, and it's already one of your factor. Your first factor is x plus 6, and your second factor is x minus 3. So to write down your factors of 2x cubed plus 7x squared minus 33x minus 18, we have x plus 6. And watch out, see how negative 6 here, but that's actually plus 6. Therefore, if this is plus, your factor should be minus 3, x minus 3. And your last factor is the depressed polynomial 2x plus 1. And we were able to find the factors of the polynomial with the degree 3, 2x cubed plus 7x squared minus 33x minus 18 by using your synthetic division. That is the whole idea of the factor theorem. Thank you.